Hey class, welcome to Shram Academy. I like to call this my little YouTube channel. It's like Khan Academy, but with Shramik. Anyways, let's rip through these practice here. Okay, so the first thing we're going to do is look at which ones are metals and non-metals, and that'll help us make our decision as to whether something's ionic or molecular. So sodium and phosphorus are a metal and a non-metal. Carbon and hydrogen are both nonmetals. So that's going to be molecular, right? Calcium and sulfur. Well, calcium we know is a metal, and sulfur is a nonmetal. And if tomorrow you just want to write nonmetal as NM and metal as little m, that's cool by me. Sulfur trioxide. Okay, so that's a nonmetal. Whoops. And a nonmetal. Oxygen. Carbon is a nonmetal. And fluorine is a nonmetal. There we go. Potassium is a metal. And nitride is nitrogen, so that's obviously a nonmetal. Aluminum is a metal. And sulfur is a nonmetal. There's only so many nonmetals, right? Not that many. All right, carbon, nonmetal, and nonmetal. Okay, so now we can go through what kind of compounds we have here. Well, this is ionic because you've got sodium as a metal. And phosphorus is a nonmetal. And I've asked for simple particle or crisscross. Right, so simple particle is pretty easy. We're going to draw 3 sodiums. And we did this one in class. And a phosphorus is a -3 like that. Okay. Alternatively, we could look at the crisscross method where we put the charges like this, Na plus 1 and phosphorus -3. You just circle the numbers and crisscross them. Boom and boom. And that's going to give us the Na3P formula. Now, since they're ionic, we do not use Greek prefixes, so we're just going to call that sodium. And then we do change the last part of the name of the nonmetal to sodium phosphide. Okay. Tricarbon octahydride. Well, this is molecular right of the gate post. And that's because we've got nonmetals only. Okay, the other giveaway. And Greek prefixes are used. And these are much more simple. So tricarbon would be C3. Octahydride is H8. Now, you'd actually know that as a molecule called propane. I wouldn't expect you to know that that's called propane, though. All right, I just do, because I've been doing this a little while. Calcium and sulfur. So that's ionic, because calcium is a metal. And sulfur is a nonmetal. And we remember that we changed the name of the nonmetal to sulfide, right? So we're going to call this sucker calcium sulfide and not monosulfide, because we don't use those Greek prefixes for ionic compounds. All right, and again, we're going to look at our simple particle to start. So we have 1 of each, right? So let's just start there. So if we only have 1, I'm going to use blue for my metal and red for my nonmetal. It doesn't matter which colors used, just use 2 different ones. Okay, they do have color codings, but I don't care. Just make sure they're different colors. So that's a +2 and a -2. And again, we can look at the crisscross method, which is a bit more mathy, and I don't like it. because we lose that sense that these things are actually particles or substances. It just turns into a math equation. So if we crisscross that, we got to go Ca2S, and then that converts to CaS, because you got to divide both sides by 2, or both of them by 2. All right, so simple particles much better, I think. All right, sulfur trioxide. Well, first off, you get your Greek prefix there. So as soon as you see those, you know that it's molecular. Okay, so that's one reason. And the main reason is only nonmetals. No metals at all. Okay, sulfur trioxide. If it's sulfur just by itself, then it's going to be SO3. Okay, no mono for the first element. There we go. Okay, now we've got carbon as our first element, and fluoride or fluorine. Okay, so this is going to be molecular. Only nonmetals are present. And that means then it gives us the permission or the rule to use the Greek prefixes. Okay, especially when we're going to do their name. Now, since it's only one carbon, we're just going to call that carbon space tetra fluoride. Again, you'll have access to a periodic table. So that's the name. Now, this is a molecule, so we don't need to do the crisscross or anything like that. Potassium nitride is ionic because potassium's a metal. And that's going to form the cation, and nitrogen is the nonmetal, and the nonmetal name changes. Okay, and we're just going to call this thing potassium. Whoa, sorry. We've already been told what it's called. Okay, so now we're going to use simple particle. Check it out. Potassium has a charge of +1. Nitride has a charge of -3, which means we need 2 more potassiums to give us a grand total and get our chemical formula of K3. Whoops. N. So only one N. And again, to reiterate, if we have a +1 and a -3 and we do our crisscross, we'll see that that works out the same ways. Okay, you're going to get the same answer. It's just less chemical in its way. All right, so there's your chemical formula. Moving on, we've got aluminum and sulfur. So that's ionic because aluminum's the metal. And we can just say that's M, little m for metal. And S is the nonmetal. So S is sulfur. And that's going to form the negative charge. Okay, N for negative, nonmetal. Anion. Okay, so let's draw this sucker out. It's saying that we have 2 aluminums and 3 sulfides. So we know when we look at our periodic table that each aluminum is going to form a +3 charge. So 2 of those are going to be canceled out by 3 -2s. And so we call this thing aluminum sulfide. I'll keep to the same ink thickness there. Aluminum sulfide. Okay. And again, crisscross, right? Al +3, S -2. So that then becomes the subscript. And it bounces out. We don't have to divide it out. There's no math to do there. We're all good. All right, the last one is obviously molecular. The tetra and the deca. Those are your Greek prefixes. And they were used to build this because this one's a nonmetal and that one's a nonmetal. We got 2 nonmetals. And so what's cool about this, it's really simple. We got carbon. Whoops. And tetra means there's 4 of them. And hydrogen, H. Okay. And deca means 10. Like the other one was called propane, this one's called butane. And that's the gas that's used in barbecue lighters. Alright, so here are the solutions and how they work, and I hope that this little video helps you prepare for tomorrow.